This week's exercise is going to be looking at natural hazards and doing an analysis to identify which community councils within the Anchorage area have high wildfire exposure, which sections of evacuation routes might the municipality need to prioritize for vegetation thinning because they go through areas with high wildfire hazard. And then we're also going to look at zoning and, are there certain land use zone codes that are associated with greater wildfire hazards? And, right now the municipality is thinking about changing its land use codes and zoning. And so with this information, they could think about what that might mean for wildfire hazards if, certain land use codes are associated with higher hazards than others. And then finally, we're just going to kind of look at changes in wildfire hazard over time so you can get a little bit more exposure with using rasters and like the raster calculator. So we're going to add our data here. So we downloaded your data from the Blackboard. And I'm just going to migrate here and find my folder. So you would add student data. I'm going to add this modified data so I don't do your guys' work for you. And actually, I'm going to add the wildfire exposure, just the 2014. And then I'm going to add the community councils. So yours will all be in one folder, but mine is kind of split up just because of some of the analyses that I did to figure this exercise out. So the wildfire exposure 2014, and then add the community councils. Okay. So I'm going to turn off the community councils here. This looks pretty ugly. And you're like, oh, what, 0 to 100? What does this mean? Black and white? Doesn't look good. Okay, so one of the things, with GIS is a big tool to relay information to the public. I make these maps over and over again, and I've had to go through several different rounds of symbology to figure out what speaks to residents. Fortunately, you can save your symbology and import it so that if you're going to be making this map over and over again, this layer, you can just import it and not have to redo your symbology each time. It's saved in something called a layer file. So we're going to go over to our wildfire exposure. We're going to right click and go to symbology. And then we're going to go over to symbology, and you have these 3 dashed lines, and we're going to go to import from layer file. So in your folder that you downloaded, you should have a layer file. You should have 2 of them. So let's do the rank first. Just click on it and hit OK. And so you will see now some colors that go from 0 to 100. And so wildfire exposure is based on hazardous fuels. And so if we zoom in here, what this says is that the pixels say in this brightest red, if you look around this pixel, it is surrounded by 90 to 100% flammable fuels, and embers are going to reach it. So it's got high exposure, high chance, of the wildfire reaching a pixel. Over in these cooler areas, there's likely cement, less flammable vegetation. The flammable vegetation that is there is far enough away, their embers aren't going to get to that pixel. And so like 0 to 10, exposure to wildfire is practically nothing. The areas of red are areas where you would be concerned and want to do some wildfire mitigation actions. Like fire-wise houses, have people remove the hazardous vegetation around their houses. Maybe get fireproof roofs. You might want to do some fuel treatments, on some of these areas. But anyway, this map did not go over well with the public. They're like, well, what does 30 mean? What does 60 mean? It was too much information. And so we're going to change the symbology to a different symbology that spoke better to people. So go back to your layer, right click on it, and go down to properties, or sorry, no, go to symbology, and then go up to that 3-dash line again and choose the other layer file this time. And this is just a quirk with ArcGIS, is it doesn't remember where you went. When it goes to get layer files, it can't remember your last folder, so you always have to re-navigate to it. Courses, GIS, natural hazards, student data, and so choose the class this time. And so now we've simplified it into 5 classes. Basically very low, low, moderate, high, and extreme. And so this is something that, okay, is much more understandable. Am I in extreme wildfire hazard? Am I in high extreme wildfire hazard? I can tell people if you're in a red, if you're in an orange, you need to do something to reduce your wildfire hazard. You know, the other reason why this is important, and I took on this project, is you can see some variation here within the Anchorage area. This is unlike many. So, for example, wildfire risks to communities. You can go to this Explore, and about wildfire risk to communities, you could watch a video, but we could just put in Anchorage. And okay, the risks to homes, medium wildfire likelihood, medium exposure. Well, let's take a look at this map. We only have 3 classes. Either you're directly exposed or you're indirectly exposed. And that really just isn't helpful for prioritizing, I think, wildfire actions. So the map that we made has much more variation within the Anchorage area, and therefore you can make some more informed decisions. I mean, this all costs money to do it, and you got to figure out where to put my money to help reduce wildfire vulnerability. So a lot of these nationwide efforts just don't work so well for Alaska. I mean, look at the Kenai. The Kenai is completely red. No, not useful whatsoever for prioritizing treatment. You know, there are national risk maps. Here's a different one too. We zoom into Alaska, and I think, let's see, Alaska has had many, 10 federal emergency management emergencies have been declared in the last 3 years, 2020 to 2022. I would say that doesn't put us in the very low category here, which this map seems to imply. Again, this map fails to really capture natural hazards that Alaska is dealing with. You know, and you can click around and look and see what hazards they looked at. Very likely, you know, the areas that are driving this are the areas with a lot of people. You know, if you don't have a lot of people in these other areas, yeah, your risk might be low. Try telling that to people who live in those areas. But that's kind of a problem if you're just looking at people when you're assessing risk. But you can see avalanche is high, earthquake relatively moderate. We have no heat wave risk, hurricanes, yay, no hurricanes. Ice storm, I would say, is higher. Landslide, let's click on Anchorage. We had a landslide in Anchorage, what, 1 or 2 years ago. Insufficient data. So again, you know, I would say that this map is totally bogus for the state of Alaska, which is why we need to do research at our scale. All right, so here we have the wildfire exposure for 2014. I'm going to turn the community councils on, but I'm going to make them clear, you know, a black outline, so I can see the data through it. Like before, we're going to go through this exercise. I do have kind of a little introduction document here. You will have questions to answer. I do have the steps all documented as far as what steps we're going to go through. We've already done this assigning the layer file. If you're interested, you could use this document too in case the video gets confusing, or if you just don't like the video. All right, so I'm gonna work our way through this. All right, so we've already done the symbology, so it makes more sense. Our first question is, which community councils in the Anchorage area, which is where people live, has the highest wildfire hazard? And we're interested in the lowest. So what we have to do is we have to figure out what is the mean or median wildfire hazard in these areas. And I'm going to walk through the mean. You guys are going to make a map of the median, okay? And I also have a question for you to tell me whether the mean or the median makes the most sense. One of my hints is take a look at the data. So take a look at this wildfire exposure data and look at this histogram distribution. Based on your knowledge of statistics and this distribution, what do you think makes sense to represent the mean or the median? Okay, like I said, I'm going to do the mean for the maps. So the tool that we want to use is something called zonal statistics as a table. So I'm going to go up to analysis, tools, and you could search for zonal statistics as table. I use it so frequently I know where it is. So toolboxes, spatial analyst, zonal statistics as table. So what this is going to do is we're going to have our input community council, and the zone field for our community council is going to be the council, which is the name of the community councils. Probably should open up the table to show you. So we basically have the name of the community council is kind of the region, and I actually already put these on here, so I'm just going to delete them because we are going to create those later. So delete, and save. Okay. And so our input raster is going to be the exposure. And I'm going to save this in a hard-coded place, not the geodatabase that's temporary with this project. I want to save it somewhere where I can go back and I can find it later. So I'm going to navigate to my data folder. And this is my folder. So I'm going to name it community council _ exposure.dbf. If you don't put this .dbf at the end, it'll fail. It will say that it can't save. Yeah, I'll just overwrite it. So if you just, take that off, it's not going to know what to do and it's going to fail. You need to have the .dbf at the end. And as far as the statistics go, just do them all. We'll do the mean, we'll be the mode is what this is, min, max, median. Just do them all and hit run. It doesn't take too long. So what this is doing is it's calculating min, median, max for the exposure within each of these polygons, within each of these community councils. So if we look at it, we can see, okay, at Clutna Valley, the median exposure value is 42. The mean is 43. I live in Spenard. So Spenard, the median is 19. The mean is 23. But this is a nice table. It's way too big though. If I presented the community with this table, even if I just showed them the mean, it'd be way too long. 37 rows, my eyes would glaze over. A map is a much better way to present this information. However, this table is not spatial. It is separated from our spatial information of the community councils. So we need to join this table back to the community councils so that we can make a map. So I'm going to clear this and close this. Prior to doing that, we need to add the categories of median and mean. That way I can make a map of the mean and you can make a map of the median. So since we're going to be adding 2 fields, there are shortcuts. I don't have to do this one at a time. I can add multiple fields at one time. The trick is to go up to Analysis, Tools, and under Data Management here, so looking, Data Management, Fields. We have Add Field, but we have Add Fields Multiple. So we can add multiple fields with one click of a button. So our input table is going to be our community councils, our shapefile. The name, let's do mean. It's going to be a double. And mean will be the alias. And click add another field. We'll call this median. It's going to be a double. All right, median. Okay. So now we're going to add 2 fields with the click of a button. So nice. There we go. Okay. So now we're going to join our summarized zonal statistics to this, populate these fields, and then remove our join. So community councils, go up to table, join, add join. All right, so it found our community council exposure. It saw that both those tables have this council in common, the name of the council. So it's going to join based on this field with which links them. And it's way too large, and I'll hit OK. So now we have our zonal statistics attached to our spatial data, but all we're really interested in is the mean, so we'll calculate that. Use the field calculator, and we'll go over and find the mean. Here it is. And we'll hit apply. And we can see it calculated it. Now we can go up here and we can change to median. So now I'm going to do this median column, and I can delete this, and I want to find the median here. So here's the median, community underscore council. We know it's coming from this other table that we joined, because we can see the name of the table here. And then we hit OK. All right, so we have the median and we have the mean. And now we can remove the rest of the data because we don't want it. So table, joins, remove all joins. Yes. Okay. So now we can make a map showing us which community council has the highest or lowest, wildfire exposure. So you could right click on here and go to symbology, and then go to graduated colors. For your field, I'm going to choose mean. You're going to want to do median. And one of the things I noticed right off the bat is the maximum value here is 60, basically less than 60. So this exposure here, these categories, extreme is 80 and above, high is 60 to 79, moderate is 40 to 59, low is 20 to 39, and very low is 20 and below. So really there's no community council that has a value, an average value that's in the high or extreme category. But still, to just kind of keep in our color scheme here, I'm going to make these 5 categories so that they match the 5 categories that we see here using the color picker. So what we can do is I can turn actually this community council off. And so I want this top layer here to have this extreme color. So if you right click on it and you go down to eyedropper, you'll click on the bright red. This one, I'll right click on this one, go to eyedropper, and click on the orange. Right click, eyedropper is the middle one. Right click, eyedropper is the second lowest. And then eyedropper and the lowest, which is the blue. Okay. All right, and the labels, I don't need the labels to be insanely long, remember that. I can actually turn that down to 0. Okay, so now I'm looking. Okay. And for now, we're just doing the natural jerks. We could break this into something that's more meaningful, like 10, 25, 35, something like that, but I'll just let it go with the natural breaks in the data. Basically, what it's trying to do is find where, looking at this distribution, where are there natural breaks in the distribution of the data. And so I look at my map, and there. I can easily see from this map which community councils pop as red, as places where, maybe we should do some Firewise education outreach activities, some field treatments, and which places I really don't have to bother about. I could go on labels and put the names, labels, council. So you could put the names there, basic polygon. Yeah, you could play around with all of this. There's a way where you can make it small so it just fits in. I don't want duplicates. Where you can get it to fit within the background, within the size of the boundary, like it'll shrink down this Campbell Park so it's small enough. I'm not exactly sure. I'd have to Google how to do that. Reduce size, I think. Reduce font size. There we go. So you can see it kind of squished in university area, scenic foothills into that. So, and that's where, your artistic flair comes in, whatever you would like to do. I would like to see a map, but instead of using the mean, yours will be the median. Remember, you go to Insert, New Layout, and usually for Anchorage, I use the letter Landscape. That's just what I do. Layout, Insert, Map Frame. Here we go. You right click to activate, remember, that allows you to zoom in and zoom out. Then you have to go off of layout, and you'll insert your legend. Properties, and I really don't need this heading here, so I can click that off. Okay. I could give this some background here. Oh, that was the border, sorry, no color. Background here, and give it some space. If I did want to have a border, I could do a border. There, put a border on. I'd probably also put that up. Click off of it, so there. Yeah, if you like rounding, you can do some rounding. So it's not so square. Where's rounding? Oh, sorry, up here. That's where I do rounding. Right up here. Okay. So now it's kind of rounded at the edges. If I wanted my wildfire exposure to be bolded, I would go to that wildfire exposure, go to properties, and that's the name of the layer. So you go legend item and go to layer names, appearance. Here's where you change it to bold. You could also make it a larger size and then hit apply. Oh, and it made everything else smaller. There you go. And obviously now these labels are a little bit too small, so that's actually the labels. You'd go and bump up the labels maybe some. There you go. Yeah, and don't forget, it's always good to have a scale bar. One of the things is, if you like that one, that works for you. You can play also with the number of subdivisions that are here. So to me that's too few. That kind of looked weird. I think what they had was good. But I hate to see scale bars that just have a ridiculous amount of breaks in here. Like, no, I don't need to have, you know, that many breaks. Nope, nope. Do I really need to know where 2.75 is? No, I don't. So I think 2 and 4 was good. There you go. And you can make it whatever one you want and do your own style. Don't forget to insert your north arrow. Choose whatever one you want. And then don't forget to put in your name. So, graded by Jen Schmidt. Date. This is June 19th, 2023. Okay. Position it however you want. Okay. And then once you get everything done, remember you go up to Share, Export. I'll save it as a JPEG. You know, navigate to your folder. MOA, wildfire exposure, 2014. Save. I do mine as a JPEG. For publications, you do want 300 DPI, and then export. And then, you know, when I say make your map, then just go insert pictures, go to your device, and insert your map. So 20 points. Okay. All right, so now we've made a map, and take a look at the attribute table and answer the questions of which community council has the highest and which community council has the lowest wildfire hazard. Okay, so the next step, the next analysis to do is road evaluation. So, you know, I've been working with communities as far as evacuation routes, and we've identified some of the main evacuation routes here through Anchorage. And so go to your data and let's add on the roads. Okay. Let's filter to the evacuation routes only, because this is a whole mess of roads in Anchorage. So right click, go to properties, and we will use a definition query, so we're only showing the evacuation routes. We'll go down to the field called evacuation, and is equal to 1. So when it's equal to 1, it's evacuation route. When it's equal to 0, it's not an evacuation route. So hit apply and then hit OK. All right, so I'm just going to make mine black here. Okay, so now we have the evacuation routes, which are a mix of snowplow routes, roads that have high speeds on them, major one-way in, one-way out corridors. These are our evacuation routes. So now the idea is we want to find evacuation routes where the wildfire exposure is extreme, so that the municipality can come in and do some vegetation clearing along these areas that could potentially have flammable fuels as people are trying to drive through them. Well, we can't do that with a raster. we need to change this raster into a polygon first, and then we can do the clipping to clip out the lines that fall within a polygon that represents extreme exposure. And since, you know, the municipality is a big place, just converting this whole raster into a polygon isn't really going to work. First, we've got to identify the areas in this raster that are extreme, save that as a specific raster, and then take that raster and convert it into a polygon. So it's a two-step process. So in order to identify the areas and create a raster of only extreme events, we want to use something called the Con tool. And one of the reasons too is because remember, this data is from 0 to 100. So if we converted this straight up to a polygon, you would have cells with 100 different values in it, which really isn't what we want. We want to identify the cells that are 80 to 100. So go up to Analysis and Tools and search for Con, C-O-N. All right, so we want the Con that says Spatial Analysis Tools. All right, so our input raster is going to be our wildfire exposure. And this where is a selection query. So we want to identify where the value is equal to or greater than 80. And that we said was our extreme exposure range, 80 and above to 100. And when this is true, we want a value of 1. When it is not true, we want nothing. So this is just a temporary raster, so we don't need to keep it. So I'm just going to call it Extreme Con. So this is the extreme values done with the Con tool, and hit run. Don't put any extension on it or anything, just extreme_con. Like I said, it's a lot of pixels, so it'll take a little while to run. Alright, so we are completed and we see we have the Con raster added here. I'm going to just zoom in and check my work. So we shouldn't really see any reds at all. It should be covered by this green, and it looks like we have successfully created a raster that only represents the red areas. So that is good. The next step is to convert this into a polygon. So go back here, and you could type raster to polygon, and you'll find it here under the conversion tools. I always like to click here because I find it helpful to learn where these are, because once you use this a lot, it's faster to actually just go to the tool rather than constantly searching for the tool. So actually we want raster, from raster to polygon. So It's the one up above, so right here is what we want, raster to polygon, under the conversion toolbox. So raster to polygon. Now our input raster is going to be the Newcon one that we made that only represents the extreme. And the field value is just going to be the value, because remember it's a 1 where it is extreme, and nothing where it is not extreme. And we want to uncheck this simplified polygons. This creates weird triangles in your data. It's like, yeah, it does weirdnesses when you convert a raster to a polygon. It'll try to, yeah, cut some of these off as like half grid cells. So I always uncheck that. Okay. All right. And since this is something that I think we want to save, I'm going to navigate to my folder. So I'm going to go to my folder, courses, GIS, this, my modified data, and I'm just going to overwrite my extreme underscore wildfire underscore exposure 2014. So I'm naming my new polygon Extreme Wildfire Exposure 2014. I've done this for many, many decades, so I've got to keep track of what level I'm at. I'm at extreme, and I've got to keep track of what year I'm at, 2014. And I also have vegetation layers. I have flammable fuels layers, so I've got to get wildfire exposure in there. Okay, so hit run. So it's converting this raster into a polygon. All right, so we're done. And just looking at it, it looks like it did it successfully. All right, the next step is to clip out the roads that intersect with these extreme areas. So we'll go to geoprocessing, and it's actually under this analysis tools up here, extract and clip. So our input data set is going to be our roads, and you'll notice it tells us that, hey, warning, 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 you only have some of the data to be clipped, and that's fine. All we're interested in is the major evacuation routes. We don't want all the neighborhoods and stuff clipped. That would be way too much for the municipality. And our clip features are going to be this Extreme Wildfire Exposure 2014, our polygon that we made. And I'm going to save this, and it's going to be our roads in Extreme Wildfire. So these are actually, I'm gonna, maybe change that to evacuation. Evacuation Extreme Wildfire. Sorry about that. I don't really need this Albers on the end either. Okay. All right, and then I'm going to hit run. So it's clipping our roads with the extreme areas. Okay, so I'm going to change this to a different color just so I can check and make sure that it's working. All right, so I can see it. I turn this off. It's clipped my roads to the places where the extreme wildfire exposure is. Okay, so now we want to know what is the total length of miles that the municipality is going to have to treat to try to minimize, to get rid of the extreme exposure around evacuation routes. So open up your attribute table. Go to the end, and if there isn't this length miles field there, create one. It's just to double, and it's called length MI. Okay, and so when this clips the data, it doesn't recalculate the length automatically. You've got to manually go and update this length to say, okay, what is the new length of this section now that it has been clipped? Because the length before was based on the whole entire segment, not the clipped one. So right click on it and go to calculate geometry. I suppose I can go over if it's not on there. You go to add field. If it's not on there, you go to add field, and then you type length and create a double. And then you would go up to fields and you would hit save. So in case this isn't on there, I'm just going to discard it because it's already on there. So go here, right click, go to calculate geometry, length, and we'll do length geodesic. It's just Alaska is pretty far away from the equator and we want it to be accurate. Statute miles. And for the coordinate system, pick your current layer that you're working with, which it should be in Alaska Albers, and it is. Okay. And then hit OK. And we'll go over and see it is recalculated. It is a different length now. And so you want to know what is the total length of miles that the municipality is going to have to treat. So you right click on that column and go to statistics. And you will see in the sum the total length of miles that the municipality has to treat. So I would like you to put that in your homework. All right, so they've got a little bit of the work cut out for them. All right, the next analysis that we want to do is looking at the land use code, since that's something hot topic in the paper recently. So let's turn off our roads and our polygon of extreme exposure and our raster of extreme exposure. And now let's go and add on our land use codes. Okay, so we have our land use codes here. Take a look at the attribute table. So pretty straightforward. We have land use codes. All right, one thing that we notice is that we have like multiple polygons for, let's say, park and natural resource. So there are two approaches to this. Our ultimate goal is to figure out what is the mean or median wildfire exposure for each of these land use codes. And so if I do a select by attribute here, I can get an idea of how many land use codes there are. So select by attribute, go to land use, and I can see there's a fair amount of them. So I want for each one of these, what is the mean or median wildfire exposure? So if I do it a zonal statistics with a raster, zonal statistics, I will get a value for each of these individual polygons for park and rec. And so, okay, I take the mean of this, and then I'm going to have to take the mean of it again, because I will have multiple park and natural resource outputs. I don't think that's the way to go. I think the way to go first is to dissolve based on this land use designation code. And then once you have a shapefile where each of these different codes is represented once, then you do the zonal statistics. So I'll just rapidly go through the first way where we don't do any dissolving. You don't have to do this, just watch me. So I'm going to go to the analysis tools, and I'm going to go down to that zonal statistics, which is under spatial analyst. Zonal statistics as table. I'm going to take our land use and put our land use in there. The field is our land use. The input raster is our wildfire, and I'm just going to accept the default where it is and hit run. So it's calculating all the statistics for every single little polygon in that land use table. So if I open this up, I only had one record selected, so it did one. My bad. Open up the attribute table and clear. We will try that again. The good thing is that it's still open, everything is saved, so I actually just have to hit run. Always make sure your records are cleared. As you can see, I did not. My bad. So this little lock means this table is being recalculated here. It'll take a little while. This way, this is another reason why I didn't really suggest doing it this way, because it's going to take some time to go through. How many polygons were there? 1600, over 1600. So it's cranking through 1600. But it is done, so we'll take a look at it. And so now if I sort here, this just surprised me. It actually didn't do it for each of the ones. It was smart enough. Funny. It was smart enough to actually do it once for each of the different land use designation codes. So it did what I wanted it to do automatically. So you could, it turns out, do it this way. It didn't preserve each individual polygon like I thought it would. Another way that you could do it is something called the dissolve tool, which actually would add an extra step that it appears you don't need. But just so you know what the dissolve tool is, I'll run that through you too. So the dissolve tool, what that would do is, you notice how we have multiple polygons for each of these different, for this land use category. So what it is the dissolve tool would dissolve based on this land use designation, so you would have one polygon that represents natural park and natural resource. So nothing is selected. I'm going to go up to my analysis tools and type dissolve, and you'll see dissolve data management. So I can click on here and I'll bring in my land use, and I want to dissolve on that land use designation, and I'm going to save this as LUP 2023 and dissolve. One of the reasons why I wanted to do it this way is that if you look at your attribute table, and I have this pinned here, which so it stays there nicely, is there is this area, miles. So if I do this dissolve, one of the things I can do is I can dissolve by this, but I can also add up the total area that's associated with each of these land use designations, which I really do want to do, because I want to know how much area are we talking about that is natural park and natural resource. So for the statistics field, I'm going to choose area and I'm going to sum it. Okay? And I do want to create multi-part features, that's fine. And then just hit OK. Run. Okay, so now if I look at this attribute table, I have 36 because there's 36 different land use, and I have what is the total area. And so I could look and see the largest land use area in the municipality is this residential. Okay, and so now if I go and do the zonal statistics on this one, and you want to do it as table, and the spatial analysis tools. So I'm going to take my dissolved land use. The field is going to be this land use designation. The raster is going to be our exposure raster. And I'm going to save this. as land use, dissolve, let's say fire, and hit run. Okay, I'm going to look at the table. Alrighty, so now I see each of the land use. I have the mean and I have the median. Wildfire exposure. So I ask you to, I asked you what is the land use code with the largest area, which I showed you a little bit before. And then I ask you what is the land use designations, the top 5, with the ones with the highest wildfire exposure. And let's base that off of the median. So what is the top 5 with the highest median wildfire exposure? Okay, so one of the other things, and why I wanted you to calculate the area for each of these land use is, imagine municipalities not having much money, and say they wanted to get their biggest bang for their buck. So where might the wildfire score per the area be the highest? So where do I have the most densely kind of packed high wildfire exposures? So in order to do that, what I'm trying to get at is where might the wildfire exposure divided by the area be the greatest? And so, we have in this table the wildfire, and we have here the exposure, the median exposure. What we need to add on to this table is the sum of the miles, the squared miles, and then another column that represents the kind of the exposure per square mile. So let's add a field to this, and let's call the first one area miles. Area miles, and we'll make it a double. And then we'll add another field called EXP PR mile, MI, and in the alias we'll make it something that's more understandable, exposure per mile. We'll make this a double. So area miles, and this, since we have to make this short, this is what we're going to make it, but in the alias is going to be longer, so it's understandable. Go up to fields and save. Okay, close that. All right, so now we want to join on that area information, which we actually got from this dissolve that we did. So we have our total area right here. So we're going to join to this layer the land use dissolve, and the field in common is going to be the land use designation. Okay, and it said, hey, it's the same column in this other table. All right, and then we'll hit OK. And so now we have our sum of our areas here. We need to populate this column here with this summed area here. So click on it, right click, calculate field. And then we'll go and find that sum area right here. All right, hit OK. All right, that's all we needed from that table. So now we can remove our join. All right, and now to calculate the exposure per mile, we want to do a field calculate field. And so we want to divide the median exposure, divided by the area. And that will give us kind of the exposure per square mile. Okay, and hit OK. All right, so now I would like you to sort this, sort this descending, and tell me which land use code has the greatest exposure per mile, which might be an indication of where they'd have the biggest bang for their buck in treatment. Okay? All right, so that's looking at land use codes. For the final little analysis that I want you to do, it just gives you experience using the raster calculator and ways that you can combine different raster layers to get other information. So I would like you to go to your map, and I would like you to add those two rasters again, the two wildfire exposure rasters. So 1984 and 2014. Add both of those. Okay. So what we have here is what the wildfire exposure was in 2014 and what it was in 1984. We are going to subtract these two to get an idea about the change in wildfire hazard over time. So identifying areas maybe where it has decreased and areas where it has increased. All right, so go analysis, tools, and toolboxes. And I'm going to collapse this. Collapse data management. Okay. So what we want to do is we want to go down again to our spatial analysis tools. And we want to go to map algebra and raster calculator. So we want to take recent data minus, click on the minus, the old data. Okay? And I'm going to try and click run and see if this works, but it might give me an error just testing here. No. So it fails, and this is important because this is a grid. It wants it to be a grid, not a TIFF file. It will not save grids in places that have spaces. So it is not going to save this in our location because I have a space in my file path. That's why, whenever I do my GIS analysis, I have it C, GIS, and BAM, the name of my folders. Spaces kill rasters. It will not work. It's not a valid output space. So what I'm going to have to do is I'm going to have to navigate to a folder that doesn't have a space. So I'm going to go to F, and I'm going to go to my temp location, and then I'm going to call it, let's see, wildfire exposure change. Let's see. Okay, and then hit save. And it still gives me this red X. You're like, oh, it can't be more than 13 characters long. So again, if I'm saving this as a grid, it can't be more than 13 characters long. However, if I'm annoyed with that, I could just put .tif and it's happy. A TIFF file can be longer than 13 characters. A native raster file cannot. So we're just going to put .tif on the end and make it a TIFF and hit run. All right. And so we have our new raster over here, and we can see, well, some places have had a 72-point increase in wildfire exposure, and some places have declined by 93. And so, again, this is an ugly-looking GIS file. So let's do the symbology and make it look prettier. So I'm going to go over here, and how about classify? And I would suggest making it, a category of 3. And the goal is to try to find places below 20 and above 20. So for here, I think I'll double click and say minus 20. And for here, I'll click and say plus 20. And so then I would go and change your symbology. And just explore it. So my question would be, do you see any patterns with an increase or decrease in wildfire exposure between 2014 and 1984? And if so, what are your thoughts? What might be driving it? Why do you think you see what you see, if you see anything? Okay? Yeah, I mean, if we wanted to move on with this and say, take this raster and change it into something that's called risk, you would bring in people, houses, power lines, things like that. And so you can combine where the natural hazard is with where the things are that are vulnerable. And that combination helps give you risk. We're not going to do it here. It would be a lot more raster calculator math, either multiplying or adding up rasters. But yeah, it's a fun process, and maybe you might find it helpful in for some of your homework. Anyway, if you have any questions, please let me know. But this is how we do a wildfire hazard analysis. All right, take care.